So we know from the question stem that all three of these machines working together can complete the task in 24 minutes. 24 minutes. And what we want to know is exactly how long it would take just K working on its own to complete the task. So I'm gonna get a variable here. I'm gonna call the time it would take K to do this job on its own K minutes. So to answer this, of course, we're going to need some more information about the individual machines. We need to know who is doing what proportion of the work. Right now, maybe K is doing almost everything, and these guys are just doing a little bit, or maybe P is doing almost everything. So we need to know more about the individual rates. Let's keep that in mind as we go to the statements. And I guess we also want to keep in mind our primary tools for calculating in combined work questions. We want to avoid calculation where possible, especially since this is data sufficiency. But these can be helpful for proving something is sufficient. All right, statement number one. Statement number one tells us that if we were to put just machines M and P together, if I just use these guys, they're going to get the job done in 36 minutes. So is this enough to know how long it would take K? Well, I really don't know between M and P who's doing more work. Maybe P is working really fast and M is working really slow. So I don't know anything about the relationship there. But I do know that they together will do the job in 36 minutes. And I know that if I were to add K to them, so I'd have all three, well, that would bring the overall time exactly down to 24 minutes. So my question is, would there be more than one rate? Would there be more than one rate for K that would bring the overall time exactly down to 24 minutes? No, right? There's only going to be one possible rate out there, one specific rate to bring us down that specific amount. And really, that's enough right there to call statement number one sufficient. We know there's only going to be one rate that makes these numbers work exactly, and therefore there's only going to be one possible answer for the time it would take K to do the job, and we could just stop right there and call statement number one sufficient. If you're not convinced, or if you're I don't know, if you want some more proof that we could calculate this, we could certainly look at our combined work formulas. And I think a good one here would be the time formula. The time formula states that the combined time to do some job for two workers, if I put two workers together, the time that they'll take will equal the product over the sum of the individual times to do that job. So can I use that here? And well, you might say, well, there's a problem. This is just for two workers, and I've got three workers up here. But we can overcome that problem if we just think about the question a little bit differently. We don't have to think of M and P as different machines. We can just think of them as this one combined MP machine. And that way I'm just combining K with this hybrid machine, and that gives me my total. So with that, thinking about it that way, we can go ahead and plug in. The combined time for the K and the MP machines is 24 minutes. And that'll come from the product over the sum of the individual times. 36K over 36 plus K. And now I've got one equation with one variable, and that I would definitely stop here to say, well, we could certainly solve that for K and answer our question. So again, statement number one sufficient, or we could use this formula too. This formula states that if I add up the individual rates, I'll get the combined rate. So if we think about that up here, we could say, all right, I'll take K's rate. What is K's rate? Well, K does one job in K minutes. So K's rate is one job per K minutes. And our MP machine, this hybrid machine, does one job per 36 minutes. And if I add those rates together, I get the combined rate, which is one job per 24 minutes. And again, we've got one equation with one variable. We could solve this. And now definitively, we've proved 3 different ways that statement number 1 is sufficient, which means B, 2 alone, is not our answer, and C is not our answer. We don't need them together, and E is not our answer. It's not the case that we'll never be able to answer this. All right, so number 1 is sufficient. On to statement number 2. And well, I want to forget about all this, everything we know from statement number 1. So I'm just gonna get rid of that information and look at just 2 on its own. So statement number 2 on its own. Statement number 2 tells us that if I take just K and P and have them do the job together, well, they will take 48 minutes. Just K and P will take 48 minutes. Is this enough to know how long it would take just K? Well, I think we can just think about this conceptually again. Okay, if I put K and P together, it takes me 48 minutes. But I have no idea who's doing more work here. Maybe K's doing almost everything, and P's just doing a little bit, or maybe P's doing almost everything, and K's working very slowly. So we just don't know. There would be all kinds of numbers for K's rate that could be combined with all kinds of numbers for P's rate to get us this 48 minutes to do the job together. So there'd be all kinds of different answers to the question. In other words, statement number 2 is insufficient, and that gets rid of D. We know A is our answer.